Welcome to the Yesterday Show. Today we're going to talk about the transition from RNA to DNA, and we're going to start out with the weather with Professor Stahl.
Well, hey guys, I'm Terry Stoll with the weather today, and well, it looks like it's really hot out here. It's like 1,000,000 degrees. There's just magma everywhere, and it's reducing environment out here, and it's crazy. I mean, there's all kinds of gases in the air, like what's that? That one looks like some methane over there. Then we got smells like carbon monoxide. That's good. Looks like hydrogen sulfide also in here. I'd say we got a little bit of ammonium out here, and so all kinds of nitrogen in the air. And we got some water vapor also. It's getting a little moist, and some carbon dioxide are floating around here too. Man, it's crazy. It's like all kinds of good gases for the lungs, but there's no there's no O2.
Hello and welcome to Rachel RNA Cooking Show. Today we're going to make some primordial soup. Our ingredients are the first early gases on Earth. We have some ammonia, some methane, water, some hydrogen, and then other gases that were found on Earth. So today we have a guest chef, Mr. Miller, who's going to be helping us out.
Thank you, Mrs. Rachel. So for our little soup, all we have to do is add a little bit of the ammonium, add a little bit of the methane, add a little bit of your H2O.
This is quite high quality H2O. You can buy it at Walmart.
Then you're going to put in some of your hydrogen. Not too much hydrogen, just a little bit. And then you're going to finish it off with your other random gases that were found in the atmosphere.
And now we're just going to let the soup cook for a little bit. And when we come back for our break, we're going to show you how to make monomers from this soup.
This show was brought to you in part by
Welcome back from the break. Now we're going to add our last ingredient.
With the help of our friend Lightning, we get our monomers, which are nucleotides.
Now, after some clay catalyzing reactions, these they're going to bond together to form a nucleic acid, or RNA.
Well, thank you very much, Mr. Miller and Mrs. Rachel RNA. We are here now with Dr. Renee for a couple of questions. So, we were curious, what is the RNA World hypothesis?
RNA World hypothesis basically states that RNA that was self-replicating came before our life now, which is based on DNA. So what happened was, we had we made our primordial soup, we had our monomers, nucleotides, and then we had them linking together. Well, so they linked together, so they're linked together, but they tended to fall apart a lot. So fell apart, there's only one here, But every so often there would be a certain sequence of the nucleotides that would stay together and have catalytic properties. So basically, the activation energy for the reaction to go is up here, it would lower it to here, so it didn't need as much energy, it could happen faster. So that would happen, and so even though there were RNA, nucleotide sequences breaking apart, the formation was faster than, the rate of formation was more and faster than the nucleotides breaking apart, so that's how our RNA was formed. And eventually transitioned to DNA, but you gotta stay tuned to find out about that.
Thank you very much, Dr. Renee. I don't understand a word of what you just said, but I'm sure someone out there did. And now to sports.
We've gathered here today for an epic duel of DNA versus RNA in the battle of natural selection, survival of the fittest. Who will come out on top? Oh, and DNA is the winner! Congratulations, DNA. Now, let's break this battle down. Why did DNA come out on top? I'll tell you why. I predicted it from the beginning. Because DNA has deoxyribose sugar, which is less reactive, of course, and more stable because it is double-stranded. It also has one less oxygen, making it less reactive than RNA. It also is more accurate and can avoid mutation by staying in the nucleus.
Also, it stores much more genetic info, and it has smaller grooves, making it harder for enzymes to attach to, which could break down the whole thing. So, it's been a great fight, but DNA will always come out on top. It's pretty good. Well, thank you very much, Mr. Miller and Mrs. Rachel. Through clay catalyzing reactions, we get